So today's video is going to be about the timeline of the atom. I started from all the way from the early 400 BC with Democritus all the way to Chadwick in 1932. So as I've said, we're going to start with Democritus. He's the first person. He was a philosopher. He wasn't really a scientist. He first introduced the atom. He thought that for his experiment to come with the idea of the atom, he got a piece of meat of bread, started cutting it until the smallest pieces, and he's like, okay, this is no longer cuttable, or as you could say, indestructible. He called this piece of matter atomos, meaning it can be cut. To Democritus, atoms were small, hard, indestructible particles that were all the same. They were all made of the same material, but were different shapes and sizes. He thought that the reason why metals were so tough because he thought that the atom had a hook, so they hooked each other. So yeah. But his theory was forgotten for 2,000 years because at that time Aristotle was there. He was more respected more respected philosopher than Democritus. But he thought that all matter, all existence was made of 4 components: fire, water, earth, and air. And he would say that your body will compose of 20% earth, 65% water, 10% fire, etc. And he believed in, obviously his theory was obviously wrong, but at that time he was well respected, and everybody believed him for his experience. And in the early 1800s, Dalton came and brought back Democritus' idea of the atom being completely indestructible, and he was an English chemist that performed a number of experiments that eventually led to the acceptance of the idea of the atom. He still believed the same thing Democritus did about the atom being completely indestructible and uncuttable. And later in the 1909, James Thomson came and he came with the model, pudding model, which believed that the atom he proved Dalton and Democritus that no, there's actually something inside the atom which were electrons and protons all over the place. That's why he called it a pudding model. Then came in 1911 came Rutherford with the theory of with the experiment of the gold foil experiment. He believed that there were positive charges and concentrated in a small nucleus. He came up with the idea there was a nucleus that controlled all the negative electrons. And he also believed that the atom was mostly empty space. And in his experiment, he shot alpha particles to a gold foil and saw that protons were after he shot the alpha particles. Protons and neutrons came out of the other side of the foil. Realized, oh, there's something that's contradicting the protons and neutrons, which led with theory that there was a nucleus inside the atom. Then later in the 1913s came Niels Bohr, a scientist who outsmarted most of the people, rival to Albert Einstein. He came with the idea of the quantum mechanics. He came with the idea that it couldn't be possible for just one neutron, one nucleus to be completely surrounded by just electrons, and they couldn't just be in one place. Like they couldn't, that it wasn't just the atom and filled with different materials and matter. So he wanted the idea that the nucleus was at the center with the proton, and there were orbitals that went around the nucleus by first. So the first orbital was filled with two electrons. Then came 8, then 8, and he said that for the idea with the quantum mechanics, because he tested you could think that as a bowling ball, and the nucleus was shot with alpha particles, and notice that you can think that it was going to make two different layers of electrons with alpha particles, but I realized that the alpha particles were going from large to smallest, and like, so whoa, how could this happen? They couldn't process it, which led to the theory of the Bohr model. But Schrödinger in the early 1920s believed that it couldn't be possible for electrons to be orbiting like this solar system. But he actually thought that in this area there was a possibility. He was all on about possibility person. So he believed in this area where you can see the flowers, where the first two electrons could be found in this area. Then later came with another symbol where they could be what could be considered the second ring, where the electrons could be found. Then they came the star. Then it continued. Then in the 1932, Chadwick, with a student of Schrödinger, thought that if the particles were shot from the alpha particles, he believed if all these protons with all these protons, the charge could be there had to be something in between that kept the protons separated, because positive and positive can be attached to each other. So in the center of the nucleus, there had to be something that neutralized the proton's energy, which came with the idea of the neutron, because it was neutral, which was canceled the energy between the protons. But Schrödinger was right about the electrons being in this new area, but Schrödinger believed that it was this form. So to conclude, this video was introduced by Jessica Parr and Juan Padilla.